Today, as Mikhail mentioned, I'm going to be talking about automated deployment pipelines, taking any models. Today, we'll focus on computer vision models and deploying them directly to the edge in a completely automated fashion. I'll talk about the pipeline itself and the solution that we've built and kind of set the stage, present some statistics and some of the components of this pipeline. And then at the end, I've got a couple fun demos to show you with the help of some of the technologies I've listed on this opening slide page: Hugging Face, Raspberry Pis, Jetson Nano, an open source project we've called Chassis, and then of course Modzy, which is where I work. So a little bit about me. As Mikhail mentioned, I am the head of a machine learning engineering team here at Modzy. And as I mentioned earlier, I work very closely with our customers. No 2 days are the same for me. I'm constantly learning new use cases, new tools, and I really enjoy kind of being in this space. For those who are in the United States, I'm on the East Coast here in Philly. I mentioned this open source project that we have built called Chassis.ml. It will be a core component of this pipeline. So we'll talk in much more depth about that later. And as I mentioned earlier, I was a tech consultant. I've served a variety of clients in the analytics and machine learning space, both US government and commercially. So again, very, very excited to be here. Would love to connect with all of you after this. Okay, so before I dive in, I think it's important to set the stage of why this pipeline we're building is so valuable. And the main reason is, we truly believe that edge is the future of AI. Some of these statistics speak for themselves, right? 43 billion devices globally across IoT ecosystems by the end of this year. Projected by the end of 2025 that 75% of all enterprise data will be created at the edge. In addition to some of these other statistics here. So it's this idea that we're all a part of AI, ML, and all the innovation that has gone on over the last couple of years. And how do we take that and bring it to the edge so that the data, where the data is collected, and ultimately where the end consumers realize the value of AI, ML, it will be right there instead of having to transfer data back and forth to data centers. But it's not an easy problem to solve. When we think about this very simply, what we're going to do today is take any sort of pre-trained AI ML model and deploy it automatically to a remote edge device. Well, when you just think about all the different tools that you could use to kind of build a model and also the different types of devices, there are so many out there. I've listed just a few here. All these different ML frameworks, languages, and then different types of devices that you might be working with. Everything from a single board computer. I've got an Intel upboard right here. I don't know if you can see that. I'm gonna hold it close to my face. Intel NUC. You've got Raspberry Pis, NVIDIA Jetson Nanos that have GPUs, to individual laptops, remote hybrid clouds, really kind of spanning the entire ecosystem of infrastructure possibilities. And when you think about kind of the components that make up these different hardware, there are different chipsets: Intel, x86, ARM60, right? So there's a lot of different factors. Just when you think about these two components standalone that you have to kind of build for within your pipeline. So let's talk about the three components that I'm going to kind of use to design this pipeline. Put very simply, we're going to take a pre-trained model, we're going to package that model, we're going to deploy the model, and then we're going to ultimately serve that model, right? And so this is kind of a simple three-step process that we'll use to go from point A to point B and build this bridge in between kind of data science and devices. And as we begin to then unpack each of these components, there's a ton of complexity involved, right? When we're talking about packaging model, you have to start by how was the model built? What types of programming language were used? Frameworks used? Are we going to build it with a container or package it in some other form that we can consume it, downstream? Are we going to build in API compatibility or accessibility? What types of dependencies, right? So the list goes on and on and on. Similarly, when you talk about deployment considerations, you need to consider the hardware that your model needs to run, because inevitably the production environment will be different than the training environment. Different container runtimes that you'll need. How are we going to secure this model? And how are we going to maybe integrate or build a pipeline such that you can integrate it into a custom CI/CD pipeline, right? Or different tooling there. And then finally, there's a ton of different serving considerations. Do we want to use Kubernetes to help orchestrate multiple model containers? Do we want to build a high availability setup? How are we going to deal with scale? What about when a device goes down, or there's any error handling, right? There's a ton of considerations. So this problem becomes very complex when you unpack these kind of different components that will make up our solution. And then finally, these are just a couple steps. So we'll simplify this more. Here at Modzy, we consider kind of the end-to-end pipeline to be a little bit broader. Not only do you package, deploy, serve models, but you have to constantly monitor those with drift detection, explainability. You need to version those models and have a good way to do so, to govern role-based access control, retrain. And so while all of that is kind of embedded within Modzy's fully managed secure platform, we will cover the first three components today, using some open source tools that allow you could replicate this on your own, do some experiments, but certainly could use kind of a more fully managed platform as well. I want to make sure nobody's from me. Oh, cool. Okay, so now that we've mentioned these different components, we haven't even talked about the device complexity. And there's a lot of factors and layers here that you need to consider. Number one, what is the operating system on the device, or what options do we have there? Number two, how do we make sure that the resource constraints are such that our model or models can operate under? How much RAM is available, number of CPU cores, is there a GPU available? What external software is needed in addition to our model container on this device? Oftentimes when we're thinking about edge use cases, there's some sort of connection that's required. For example, if you have a camera that's feeding data to a model, you likely will need some software that can connect the two, right? And so you want to make sure that the pipeline you're building can account for that and be flexible. Security is a huge deal. How are you going to secure your application, or is it going to be accessible to the public? How are you going to put up any guardrails or security policies? Similarly, what does networking look like? And I'll talk about that in more depth in a second. And then finally, some of the model requirements specific to devices that, again, we kind of covered a couple slides ago. Okay, so we're kind of working our way there, right? We started with different components in this pipeline that we'll build. We talked about the device itself, and suddenly there's a ton of variables, factors, complexities that we're working with. I think one way that we like to think about and understand the impacts of all these considerations is looking at devices segmented by power availability and network connectivity. As one example, you might have a 5G MEC tower where there's a bunch of MEC servers co-located with the 5G tower. And you may want to build some application that powers mobile through AI ML. Well, in that scenario, it makes sense to have the models very near that network tower instead of deploying them directly to the cell phone itself, so that through that network and through that power connectivity, you can really deploy AI solutions out quickly. On the other end of the spectrum, you may have a facility, an industrial facility with a bunch of single board computers, small form devices that have microcontrollers embedded into them with very inconsistent network connectivity and obviously very low power. So you have to build a pipeline, and this is what we'll eventually get to, that is flexible and efficient across device type. And thinking about devices from kind of this near edge to far edge kind of ecosystem, what we like to think about is actually design patterns, something that we call design patterns. So how are we going to design a solution that is agnostic of these design patterns and can deliver the most value to customers, based on the settings, use cases, devices, and models. So I won't go through all of these in depth, but some of the examples and demos that I'm going to show today will be some of the native edge. Will fall into the native edge category. The first one is native edge. This is the idea that you're going to deploy a model directly on a device that's capturing the data. So this is where we'll use those single board computers, small devices that have sensors attached to them or cameras attached to them. Network local is similar, but network local can handle larger workloads. So you may have an enterprise edge server, let's say like an HPE EL8000 deployed in a factory, where you may have tens or dozens of models deployed on that device, but that device has the power to run all those at the same time, and similarly connect to dozens or hundreds of different data sources at the same time. A third design pattern is something that we call edge cloud. This is the idea that your workloads may be highly variable. So you may have some cases where you want to have several models running kind of in more of an edge server environment, and models that need to run directly on small form edge devices. And so this might be where you deploy your entire MLOps platform to a manufacturing facility, as an example. And then finally, remote batch is what we kind of consider to be taking models and sending them to remote Spark clusters, where that Spark cluster is the edge device, where you may have these data centers globally or regionally collecting big data, and instead of transferring the data, which just is computationally and timely very expensive, right? You can send models and execute remote batch jobs directly in those remote Spark clusters. So just a couple of design patterns we've seen. We've worked through various use cases with some of our customers. But again, what we're here to talk about today is this native edge concept. So this diagram, I think, does a good job depicting what I'm going to be showing and demonstrating. Where on the left, we'll start with our central MLOps platform. You can think of it as kind of a control plane that has all your models, kind of has all those features that I talked about a few slides ago embedded there. And then what's great about this is you can automatically orchestrate and facilitate the remote deployment of models to a single device or a fleet of devices. So in this case, what we're doing is pushing models directly to a device where it will be operating on, where the data is right there. So, edge client example number one would be an NVIDIA Jetson Nano. I'm going to show an example of that today. Number two would be a Raspberry Pi. I'm going to show an example of that today as well. So just wanted to kind of set the stage. These are all the things that we've thought about that have gone into the solution we've built, and some of the best practices that we like to share when you're thinking about building some of these pipelines yourselves. Okay, so with that, I'd like to dive into the demo. And there's going to be a two-part demo. The first, I'll demonstrate the pipeline itself, kind of the core elements, and I'll walk through an example. And the second, we'll actually show an application of this pipeline for a real life use case that we've kind of helped our customers build. So it'll be a prototype version of something that we've seen and helped some of our manufacturing customers implement. Okay, so the pipeline itself. What we'll be doing today, I'll have a Jupyter notebook open, so just a local Python environment on my machine. And what we're going to do is take some YOLO V8 model that we'll find on Hugging Face, and we'll use this open source package I mentioned earlier. It's called Chassis.ml. So Chassis, the goal behind Chassis is to enable data scientists and machine learning engineers with the tools they need to operationalize models, the ones that they're really good at building, without having to know Docker or Kubernetes or how to build APIs and embed web servers, into containers. All of that is done for you basically with Chassis, because all it is a Python package that allows you to connect to a service that will take any Python model, automatically build a container out of it, and that container is suddenly portable, transferable. You can deploy it and run it on all sorts of devices. So we'll show you what that looks like. And then the second environment that we're going to be working with is a remote Raspberry Pi model. So this is actually not at my house. I showed you an example of a single board computer I do have, but this is located at our head of products house down in Virginia, so a couple 100 miles away from me. And what I'd like to then kind of demonstrate are two different routes that you could take when executing or replicating this pipeline on your own. The first would be, it's a Docker container, and I'll show you what this looks like. You can download the container, you can spin it up, and it exposes 3 remote procedure calls that allows you on the client side to interact with that model through gRPC APIs. So it's something that you could do and kind of spin up a little bit more manually. The route I will walk through in more detail today is a little bit more automated, and it leverages Modzy's edge feature. So what we'll do is we'll take that container, we'll deploy it to Modzy. Within Modzy, we'll basically configure an edge device group, which you can think of as a configuration group that maps models to a single device or a fleet of devices, and see how we can make API calls against that remotely. So let me stop here. I'll kind of switch back and forth so we can get our bearings before seeing the second demo. So let's go to my browser. Mikhail, can you see my browser now?
Yes, we do.
Awesome, great, thank you. Okay, so as I mentioned, we're starting on Hugging Face. I'm assuming most people on this call have, at the very least, heard of Hugging Face, right? It's awesome. We're big fans of it here at Modzy, use it all the time. So what I've done is just I found a yellow V8 model that detects protective equipment on individuals. It's great for manufacturing, construction, some other use cases. And specifically the supported labels, as we see on the model card, are things like gloves, goggles, masks, and the opposite of that, right, and shoes. So what I'll do is essentially copy this code in terms of how do I use this. It's using the Ultralytics Plus package in my notebook, and run a couple of things live for you. Okay, so the first, let's see, this is all imported directly from Hugging Face, downloading my model, setting some model parameters, make this a little bit bigger, setting my labels, and then we've got this image of from GitHub of a very popular soccer manager, Zidane, right? And so we're just going to pass this through our model, and the Ultralytics package has this pretty cool render results capability. I don't know if you saw this, but my this picture just came up on my machine, and we can see that the model predicts that this guy's wearing no goggles. So not the most appropriate picture for this use case, but it's kind of fun. I maybe should have done one with Ted Lasso or whoever other popular soccer managers are. Anyway, so now what we're going to do is we're going to take this model and just reformat it a little bit so that we can use it with Chassis.ml. Before going into the code, I'll just go to the Chassis website right here. So again, this is totally open source. If you go to Chassis.ml, you can check it out yourself. Would highly recommend doing so because there's a lot of great resources we have, on this site, including a totally self-service getting started guide that you could follow and see how easy it is to make a container out of just a simple scikit-learn model. So I won't go through this in depth because we'll talk about how Chassis works here a little bit more. But again, would very much encourage you to go check that out if you're interested. So we've got our model, it's loaded in YOLO V8 model. And all we have to do is define like a predict function. I'm going to call it process, but you can call it whatever you'd like. The sole parameter to this function is some raw bytes. So we're working with an object detection model, and obviously that takes imagery. And so we're expected to decode these bytes and format that into the way that the model expects. So fortunately, OpenCV and NumPy makes it really easy to do so. So we'll read in our image bytes and we'll pass it through our model predict function. And then, there's tons of ways you could do this. It's totally up to you how you'd like to format your output. But for convenience purposes and for downstream tasks and application development, we found that returning things in JSON makes it really easy, scalable, and predictable to kind of build applications. So we're just going to format the outputs in this format, pretty standard. And then what we'll do is start actually leveraging Chassis. So again, I pip installed the package. We'll start by connecting to the client with some service URL. We publicly host one at chassis.app.modzy.com. So anybody can use that. Again, we host that in our cloud. And what I'll do is create a model, a Chassis model object. You'll notice all I need to pass through here is this process function. And after doing some testing, we can see what the raw output looks like. Again, we see a similar prediction to that returned on this image. So that's cool. And then what we'll do is define a content environment. Here's where you have the opportunity to define some packages that your model needs to run inference. And when you execute the publish method, Chassis will take all of that. It will take the dependencies that you've defined here. It will take the Chassis model object itself. It will serialize it. We use MLflow under the hood, it will build a container out of it automatically and then push it to a Docker registry. So we'll notice here, I had previously passed through some of my own Docker Hub credentials. This takes about 5 minutes or so, so I'm not going to run this part live. I did run it ahead of time, and just so you can see what the output looks like, I've got my own repository here on Docker Hub, and I built most of these with Chassis. But what we see here is simply a container. Now, you'll notice that I'm going to run this on a Raspberry Pi, so I set the ARM64 flag to true. You could, by default, will build for AMD 64, but there are several other architectures that we support. So super convenient and easy to build for kind of whatever target architecture you're working with. Again, very important when you're trying to take a model and deploy it to an edge device. Okay, so we've got our model here. And now what we can do is deploy this to Modzy. For the sake of demonstration, I'm going to show you how to do this in our UI just very quickly. But we have APIs that we've used to basically programmatically automate all this. And since it's just a couple lines of code, a couple of easy to use APIs, you can seamlessly integrate this into a variety of CI/CD tools. So if I were to deploy this myself, I'd go over to my Modzy page where I've got my library of models. I'd add a new model and see some of the no-code options we support out of the box. But if I've got a chassis model, I'm just going to simply import a model here. So we'll call this PPE detection on this, just because I like to be very crystal clear here. And so then what I'll do is simply go through this 5-step, very easy to use TurboTax-like deployment process. So all it requires is if I go over to my Docker Hub page, copy this right here, choose a Docker Hub option. I'll paste in the Docker Hub container registry link. You can just do Docker pull, and you'll see Modzy instantly begins to download this container, right? So then, again, this also takes a couple minutes because there is a non-trivial amount of download time based on files you're using, et cetera. But then I'd have the option to go in and configure and customize the hardware requirements. You can do documentation, you can test the model, and there's a lot of very convenient functions here when you're thinking about deploying your model, all taken care of. But that's not what we're here for. We're here to see what the rest of the pipeline looks like. In other words, taking this model all the way through to an edge device. So in Modzy, the way that we set this up is through something called device groups. I've gone ahead and created a device group ahead of time called protective equipment detection. And you can think of this as again, a configuration or mapping of a single model or multiple models, right? I could add different models to this particular device group to a single device or set of devices. So I've added a model that I already deployed ahead of time. And then what you can do is go create a device token. This device token is kind of the key to unlock this magic, so to speak, of taking a model and remotely deploying it to any device. So I'm working with the Raspberry Pi, which has a 64-bit ARM chip. And so all I have to do is generate some commands here. And what we see are 3 commands that I could run on my Raspberry Pi to do some pretty cool functionality. The first will download a very small binary. This binary is an executable that contains a subset of the Modzy software that allows us to spin up models, orchestrate models, and ultimately submit APIs to those models and run production inferences. Then I'd simply need to chmod to make that file executable, and finally pass through my device token to do 2 things. Number 1, register the device with Modzy Hub right here. And number 2, download the models that I've included in my device group. So if I click on this devices, we're seeing that it's offline right now. And so what I'll do now is pull up a terminal and run this Modzy core resume command. Now, what's happening here? I've already run the commands that I showed you a second ago. What we're seeing is Modzy core is spinning up a container that's already on this Raspberry Pi. See, we're getting some messages here. It's starting the container. If I go back to my Modzy Hub page, let's take a second. Basically, it's spinning this up. It's got a container already on this device, and it's preparing it so that I can run inferences against it. And this will take just a second. All right, so you should see my screen now. We see it's live and running. Awesome. Now, if I go back to my Modzy page, what we should see is a little ping here. Yeah, so I'll come back to this. This pings it every couple of minutes, and we'll see some. So what that means is there's a live telemetry tunnel between this device and Modzy Hub. It's pretty cool. So we've got my model running. We'll go back to my notebook. In this case, just remotely send an API call, an inference to this Raspberry Pi. So to do so, we need our model identifier and version. If I were to go into Modzy again, oh, there we go. We see it's healthy. If I click on this particular device, we see some device-specific information, the operating system, how much RAM, CPU cores, and then importantly, something that's consistent throughout the entire Modzy platform is very easy to use copy-pastable code on a per model basis that allows you to run inferences very easily. So we see that every model has its own unique identifier and version. So again, that's what all I'm doing in my notebook right here, identifying that. I'm going to use the same image and send it through as raw bytes and submit an inference. Now, if I go back to this, my terminal, you see a lot of crazy logs, and I will not make you look at this because it's a little bit tough to see it, look at it in the eyes. But what's happening is I'm sending data from my local laptop, I'm in Philadelphia, to the Raspberry Pi in Fairfax and getting results right back out. We'll notice that it's the same format that I set in my process function up here, right, in the chassis code. And again, this allows me to very easily build applications. Again, the soccer image may not be the most relevant, but this becomes super relevant when you have a construction site and you want to enforce the construction workers wearing their equipment for safety measures, and you can connect this to custom alerting mechanisms, lights going off, alarms, things like that. So what I've done here is shown an example of this pipeline, again, that uses Chassis to take any model, build a container out of it automatically that can run anywhere, and Modzy's Edge feature to remotely deploy it, automatically exposing these APIs, making it really easy to use. And so now that I've shown you kind of the core components and principles of our design, I wanted to show you how we could apply this to a real life use case. This is a use case that we helped a manufacturing customer build for defect detection. So I'll kind of walk you through this journey here. With a 3D printer, we printed out some spur gears. You'll see what that looks like in a second. And on some of the gears, we manually made some defects on them, dents, broken teeth, scratches. You see what that looks like. We took that data set, we labeled it, and we trained a YOLO V5 model. So this YOLO V5 model is trained hyper-specific for just a prototype to detect defects on these small gears. Then what we did is we applied it and applied our pipeline. We put this model through our pipeline and built a container out of it, deployed it to Modzy Hub, which is deployed in US West 1 region of AWS, and then remotely deployed it to a Jetson Nano. So while this is still up, let me kick that off here. I'll bring this in here. All right. So this should all be running now. Very good. Okay. So this is what we did. Now, there's a small webcam connected to our Jetson Nano that's constantly looking at a rotating plate, right, with all these parts on them. And then we built a very simple web app that could simulate something that an operator might build to kind of keep track visually of the parts on a conveyor belt for automated QA. So what I'll do now is go back to my browser, go to this defect detection dashboard, and what we can see here are a bunch of things happening in real time. We can see the top-down view of the camera that simulates what a camera on a conveyor belt might look like, with kind of the rendered predictions over top, in addition to the table being updated in real time. And then if I scroll down, we can see it's some kind of manual lights and alerts that we connected. This is the Jetson Nano again, right there. where anytime you see a red dot, that's reflecting a defect. Now, hopefully, we would see very few defects on a real manufacturing plant, product assembly line. But nonetheless, you can see how an operator might be able to leverage this, totally customize it with easy to use APIs, and build some pretty cool applications on top of it. Okay, so that was the final demo I wanted to show. And just to wrap things up, this pipeline that we built leverages a couple different computer vision models, but can be applied to a variety of AI ML use cases relevant at the edge. For example, image and video analytics, we see this all the time, smart surveillance, smart cameras, object detection and recognition, as I showed today. Text and audio analytics is a great use case for telco providers, as an example. Intelligent search, chatbots, automatic speech recognition, to all sorts of machine data use cases that collect a bunch of sensor and IoT analytics on predictive maintenance, wearables, the list goes on and on. So I just wanted to kind of share that this pipeline we've seen used across a variety of use cases, and wanted to throw one last plug in here for Chassis. Chassis is kind of a core component to this pipeline that we've built. And we, in the next couple of months, are going to be releasing Chassis 2.0. As I mentioned, it's open source. The models the containers that come out of Chassis adhere to this very specific spec. Those models can run on Modzy, can run on Kserve, can run standalone. And these are just some of the features that we have coming out. So if you're interested, go check out our docs site, the GitHub page, and open an issue. If there's any specific use case, we would love to hear about it, and are looking for contributors as we continue to grow this community. With that, I just wanted to say thanks again. It's a topic today that I really like talking about. We have a ton of fun working with our customers on it. The edge AI space is ever growing, and would love to hear your stories, hear your feedback, if anybody has any questions or wants to connect afterward.